Hey everyone, welcome back to Loot Code. Today let's break down the bubble sort algorithm, which is one of the most popular sorting algorithms. Alright, so let's see. This is a given array 15, 13, 8 and 7. Right, so the basic principle in bubble sort is we will compare two adjacent elements in an array, say let's say 15 and 13 for example. So we will compare these two. We will check if the previous element is greater than the next element, if 15 is greater than 13. If it is, then we will perform the swapping operation, or we will simply go and check the next element, next two adjacent elements. Okay, so let's go about the iterations, or it's popularly called pass. So pass 1, we have 15, 13, 8 and 7. Let's compare these two adjacent elements. Is 15 greater than 13? Yes, it is. So we will swap it. 13, 15, 8 and 7. Now let's compare 15 and 8. Is 15 greater than 8? Yes, it is. 13, so we will swap it. 8, 15 and 7. Now let's compare 15 and 7. Is 15 greater than 7? Yes, it is. So we will be swapping it. 13, 8, 7 and 15. Okay, so 15 is now in the right position that we want. So when we're talking about sorting, right, in any sorting algorithm, by default it means ascending order, sorting in ascending order, right? So now we have 15 in the desired position. So we can move on to pass 2. So this will be pass 1. Pass 2, we'll continue from here. 13, 8, 7 and 15. 13, 8, 7, 15. We will compare 13 and 8. Is 13 greater than 8? Yes, it is. So we will swap it. Now is let me finish this. 8, 13, 7 and 15. Now is 13 greater than 7? Yes, it is. So we will swap it. 7, 13 and 15. Compare 13 and 15. Is 13 greater than 15? No, it's not. So we simply write it as it is. So this was pass 2. Okay, now in pass 3 we will continue from here. 8, 7, 13, 15. 8, 7, 13, 15. Compare 8 and 7. Is 8 greater than 7? Yes, it is. 7, 8, 13, 15. Is 8 greater than 13? No, it's not. 7, 8, 13, 15. Is 13 greater than 15? No, it is not. So we will simply write 7, 8, 13, 15, and there you go. This is the sorted array that we were that was desired. Okay. Hey everyone, so let's sort this array 15, 13, 8, 7 using the bubble sort technique. Okay, this is the iterative method of sorting this. Next we will also look into how to solve this recursively. Okay, so let's get into the program. Hash include stdio.h. First I will write a function void sort, and the parameters are the receiving parameters are an array and the size of the array. First I will run a for loop. This outer for loop is for the passes, pass 1, pass 2, pass 3 and etc. For int I equals 0, I less than n minus 1, because if there are 4 elements, we will be passing n minus 1 times, so 3 times. So 0 to 3 will be 0 to I less than 4 minus 1, 3. So 0, 1 and 2 will be the iterations. And I plus plus. For int j equals 0, j less than, again n minus 1, j plus plus. If, we'll check the condition here, if arr of j is greater than arr of j plus 1, then int temp, this is the swapping logic where I'll keep a temporary variable. Int temp is equal to arr of j. Arr of j is equal to arr of j plus 1, and arr of j plus 1 is equal to temp. Alright, this should do it. Let's go to the main function. Int main So here I will initialize the array is equal to, and let me copy paste this, 15, 13, 8, 7. Int n is equal to size of ARR by size of ARR of 0. So I cannot simply write size of array because that will return a value in bytes. So the size of array divided by the size of one of the elements will give the number of elements in the array. So that is what we want when we're talking about size. Okay, now let me call the function sort, and I will pass the array and n. Next, I will run a for loop for int I equals 0, I less than n, I plus plus. Before that, let me print here, printf the sorted array is, and inside the for loop, printf percentile d. Let me give a space here after the format specifier so that it looks good, and here it will be a of I, return 0. So this should do it. Let me save and run the code. So there seems to be an error. Yeah, this is ARR of I. Save and run, and there you go, 7, 8, 13 and 15. The original array was 15, 13, 8 and 7. So we have sorted the array, and the sorted array is 7, 8, 13 and 15. Now let's modify this function to make it a recursive method, right? So I will rewrite this function. So void sort, and my parameters will remain the same, int ARR and int n. My base condition will be if n is equal to 1, that is if the size of the array becomes 1, then simply return back to the main function. So the control will go back to the main function. Okay, else for int I equals 0, I less than n minus 1, I plus plus, if ARR of, see here it's only one for loop because the passes will be taken care by a recursive call, which will come after this for loop. So if ARR of I is greater than ARR of I plus 1, then int temp is equal to ARR of I. ARR of I will be equal to ARR of I plus 1. ARR of I plus 1 will become equal to temp. Yes, and outside the for loop we will call the function sort. Let me correct this, it's sort, sort. Sort ARR and n minus 1. So let's say this is the array, right? 15, 13, 8 and 7 is the array. So in the first iteration, I is 0, I less than n minus 1, which is I is less than 3, I plus plus. 15 will get pushed to the right end of the array. And then when we are passing it, when we are calling the function sort again, the already sorted element we will ignore and the other 3 elements will be passed. So that is why the size decreases. So 15 will go to the end of the array, and we will call the function sort with the array of a size 1 lesser than what was already there. So if you trace the program, if you take a pen and paper and trace the recursive call, you will be able to understand. Alright, so let me save and run the code. This should work. Okay, in line 20. Yes, save and run the code. Again, the sorted array is 7, 8, 13 and 15, which is the right answer. So the code works.